antiderivatives today. That's the end of chapter 4. It fits better with 5, so that's why I put it in 5. Nothing on the test had to do with this. Okay? Capital F is called an antiderivative. Hey guys, capital F is called an antiderivative of F if its derivative equals little f of x. How do you know you have an antiderivative correctly? Just take the derivative. You better be back to that. So what if I integrate this one, f prime of x dx? What's that equal to? That's equal to f of x plus what? C. Don't forget that arbitrary constant. You have to add the constant in because you could have had a curve like this. And if I bring this little green curve up, does that change the slope of the tangent lines? No. Be careful. The C is a shift on a polynomial, like x squared. Some of the other ones on the sine function it is too. But it isn't when you do the logs. You have to be really careful about doing the logs and the exponentials. But that's where we're at. So how do we find the antiderivative of this one? And I'll print out another sheet if you want, the sheet of the derivatives and antiderivatives. Well, what's the antiderivative of the sine function? You guys remember that one? Okay, how do you know if you did it right? I take the derivative because that's the easy one to mess up on the sign. The derivatives of all the cofunctions are negative. I don't think about what the antiderivatives are. It's too much to think about. So instead, I go back here and I look at that and I say, oh, what's the derivative of negative cosine? It's positive sine. Now, how are you going to do the next one? We don't know how to do anything with a product rule or a quotient rule. Okay, Nick? We don't know how to do those. So could I transform this into something I know how to do? Zach, how could I do this? Nope, we're not doing substitutions. All we know is the power rule. What is the power rule? Okay, n plus 1 over n plus 1 plus c. This works for all n except one value in particular. Negative 1. Because the antiderivative of 1 over x dx is the log of, and don't forget the absolute value sign, that could come back and haunt you on the exam. You need that absolute value sign. Sometimes you don't on the exam, and then we don't even look at that. Because I graded that one with the log, and they said, well, you know, it doesn't come into play on this problem, so if they didn't put the absolute value in, no big deal. The problem is, if it is a big deal, if it does come into play. And so sometimes there are exam questions that have that. Most likely you will get a logarithm or an exponential. And it will be in a differential equation if you remember those. Okay? So you know what I'm going to do with this? I'm going to go ahead and divide that out. Now, I didn't leave myself any space. But what happens if I divide these guys? What am I going to end up with, Trevor? 2x to the 5th. You should have a handout. 2x to the 5th divided by x. So you have a handout on this. Okay? It's 2x to the what? No, you're dividing. So you subtract exponent minus, and then this is x to the 1/2 over x. What's that going to give you? X to the what? What do you do with the exponents? You subtract them. X to the negative 1/2. All you have here is power rule. That's it. We're not doing U substitutions. So I'm going to move this down. Hang on. And turn this up a little bit. So G prime of x is equal to 4 sine of x. And then if we divide x to the 5th by x, that should give me plus 2, x to the 4th minus, and then when I take the square root of x over x, I get x to the negative 1/2. I can't do the problem if I leave the x in the denominator. We don't have a quotient rule. We don't have a product rule. You won't like it when we get the product rule. Okay, that's integration by parts. Okay, Alex, what am I going to get now? Alex? So I'm going to get what? I get g of x equals negative 4 cosine x. Now it should be easy 2x to the fifth over 5. If it's free response, just do the n plus 1 over the n plus 1. Don't worry about simplifying them. If it's multiple choice, you will have to. Then this is minus x. We're going to go up 1 to the 1/2. Divided by 1/2 is the same as multiplying by 2. Dividing by a fraction, same as multiplying by its reciprocal. Plus what? C. Done. The C is very important. When you do the differential equations, or like on the next example, if you don't add in the C, you're not going to get very many points. And I don't want to see you do that. Okay, I'll make this bigger for those who don't have a handout. There we go. We want to find F. Now, you want to make a list of all the derivatives we do know. I did do that in the other classes, the AB classes. So the list would be, first, I'll start over here, then I have enough room. X to the n dx is equal to x to the n plus 1 over n plus 1. Now, everything you guys do here has to look like one of these. Now, this is only true for n not equal to negative 1. What happens if n is negative 1? Okay, Matthew? Then I get a division by 0. That's when we can't do it. Okay, so you need to know this one. And another day I'll explain why we have to have absolute value. Right now, just take my word for it. Okay, what else do we have? We've got a bunch of these. What about the antiderivative of the sine function? So we have the trig. I may not get everything, but that's equal to negative cosine of x plus c. I just know the derivatives and work backwards. Ooh, it's a little crooked. What's the antiderivative of the cosine? Sine of x. Okay, guys, question? What about the antiderivative of secant squared of x? That's tangent of x. Can I integrate sine squared? Not yet. It's composite. Can I integrate the log function? Lori, can you integrate the log function? Not yet. We need integration by parts. These are the only ones you know. So could I do cosecant squared? Yes. Okay, guys? Okay, you don't need your calculators right now. What's the integral of cosecant squared? Derivative of what gives you that? If the derivative of tangent gives you secant squared, what is the derivative of what gives you cosecant? Okay, is it positive or negative? The derivative of the cofunctions are what? Negative. Where? I don't think I've made a mistake. Sorry, I wanted to make that look nicer. I didn't like the way that looked. The derivative, when you do the sign, when you take the derivatives of the cofunctions, you get negative. So when you anti-differentiate and you get a cofunction, that will be negative. What about this one? Oh, what about this one? Let's get them all. What's that one, Ori? Derivative of what gives you secant tangent? Not cosecant. You're close. Secant. The derivative of secant is secant tangent. Nope. So if I do cosecant of x, cotangent of x, what's that going to be? Negative cosecant. And you want to know them fast because when you run into them, like we are in this problem, you got to be able to figure out what they are. Every single antiderivative you want to find has to be transformed to look like one of these. That's when we're going to use the U substitution. Okay, there's two more we need to know. I almost did that wrong. What about this one? Not tangent. Inverse sine. If you put a negative in front, it's just negative inverse cosine. Who cares? It's the same thing. What about this one? Inverse tangent. I think I've got them all. Log was one of our functions where we could differentiate, but we can't anti-differentiate just yet. We will. That'll be in this chapter. So we'll do some BC topics. This is all review. Okay, so Eric, you don't have that written down. It'd be kind of nice to have it written down someplace. You want me to bring it back up? I will save it, yeah. Okay, you guys ready? Now when you try this problem, you want me to slide it back? Okay. So you guys who have the yellow packet, you could try the next one. So let's write this way. F prime of x is equal to e to the x. I don't like the way it's written. And it's 20 over 1 plus x squared. Now I'm much happier about the way that's written. Oh, I forgot one. Oh, I forgot this one. Because it's too easy. What's the antiderivative of e to the x? E to the x. And the problem is if you don't put the plus c in, if you put the c in too late on the exam, again, we penalize you harshly. In fact, we even make up a little story about the forgotten C, or the C that arrives too late. So, how many points you get. Nick, what's the antiderivative of this one? Antiderivative of e to the x is e to the x. You guys need to be doing math in math class. No, you're playing with the calculator. We're doing this. You guys, it's not that hard. You guys, it's not that hard just to pay attention in class. That's the best way of learning. Don't get a tutor. That's kind of ridiculous. If you're not paying attention, what's this one going to be? 20 times what? Antiderivative of that is what? Inverse tangent plus c. Guess what? We can find out what c is now. That's the initial condition. I have an initial condition that when x is 0, the y value is negative 2. So now that places this function in a certain place in your graph, and I want to know what that is. Not necessarily negative 2. Well, let's substitute in here. This is negative 2 equals e to the 0 plus 20 times the inverse tangent of 0 plus c. This is negative 2 equals 1. And what's the inverse tangent of 0? Do we remember that one? That's 0. So 20 times 0 plus c. So c is equal to negative 3. Okay. And that's what you put in for c here. C is negative 3. Okay. Ready to try another one? What if you have the double derivative? Now, you know what? I just realized this. This is a little problem in this book. Okay, you guys? When you're given a derivative like that, that's a differential equation. You remember what a differential equation? Equation which involves derivatives and the solution is a function. So, but these are first order ones. We know how to do those. Second order ones, when it's a second derivative, if you have it all kind of mixed up with some other things, you can't just integrate. So in a way, I don't really like this because these can't always be done. This is a second order differential equation. But because all of these are on the right side, so let's undo that. There's a little bit too much. All of these variables here are on the right side, it's going to be okay just to integrate that. So first thing, let's find f prime. Somebody want to come up and do this? What's f prime then? This is just a nice little polynomial. It's 12x to the what? Third over 3. You know, I've been doing this a long time, but I still write it out because I like to get it right. Okay, Joanna? What's the next one? Squared over 2. Yeah, I know. You guys are smarter than me. I know that. Minus what? 4x plus c. I could put over 1, but why? Okay, so before I do the problem, I'm going to clean it up like you guys told me what to do. But and now we know that f prime of 0 is 4, so you can put 4 in here. This is going to be 4 times 0 cubed plus 3 times 0 squared minus 4. I love it when these are zeros because then it's easy. If they're not zero, then it's not so easy. So c is equal to 4. I'm not done. Now, where are these used? These are used in physics problems when you're given the acceleration. And unfortunately, they're not always going to be nice numbers like this. So I'm going to put f prime is equal to 4x cubed plus 3x squared minus 4x plus c, but plus 4. And now let's find this antiderivative. Basically, I'm integrating both sides with respect to x. So f is equal to x to the 4th. Check, is that right? Plus x cubed minus 2x squared. Is that right? Oh, I made a mistake there. Fine, because this 3. Okay, this is what? X cubed, right? 2x squared, right? Plus 4x plus, well, it isn't the same c, so let's call it c. I don't want to get myself confused. If I call it c, I might think it's the same, but it's not. Well, it's just a different constant. And it goes through 1, 1. So can you find d? Sure. What's the y value? 1 equals 1, 2 plus 1 plus d. 2 minus 2. 1 plus 1 is 2, minus 2. No. This is 2 minus 2 is 0, plus 1 is 1 plus d. Why are you getting 4? Oh, I skipped a term. 4 times 1. Sorry. Okay, these go. So 1 equals 4 plus d, so d equals what? There you go. I know. Here's ours. Okay, one more problem on this. This one's a little trickier. This should say, oh, am I missing one? Oh, I know. I did that last one wrong. Now, I didn't really do it wrong, but in the book, they do it and they say f prime of 0 is not 4. They say f of 0 is 4. That changes the problem. Well, the way I did it, because I typed it wrong, it's minus 3 for the d. But the thing is it was supposed to be f of 0 is 4. Now, let's see if I can write small enough. If that's true, then I get f prime is equal to 4x cubed, because you're going to have to do a little work, plus 3x squared minus 4x plus c. Now you have to integrate that. So f is equal to x to the 4. Because I typed this wrong, the original problem is this. Does that change the outcome? I didn't. Yes, you can. That's why I wanted to make sure you see that. What's this? This is x cubed minus 2x squared plus cx plus d. Now you have to use these two conditions to find c and d. Let's put 0 in. This gives me 4. That's all 0 plus c. So, sorry, I wrote that wrong. If you look in the book, that's how they did it. 4. I can't put it in there. Sorry, I've got to put it in the bottom one. 4 equals 0 plus 0 minus 0 plus 0 plus d. D is 4. Then I can find c by substituting 1 in here. So 1 equals 1 plus 1 minus 2. Did I lose my 4x again? No. Plus cx. I don't know what c is. Plus c times 1 plus d, but plus 4. And you can solve for c. Different situation. I copied it wrong. typed it wrong. It still works. Okay, you guys, who wants to try this one? Eric? Okay, f prime. You know, okay. Okay, yes, we do. Because we can't use the power rule on this. Okay, let's find c. It says f prime of 1 is 0. So this is going to give me 0 equals minus 1 over 1 plus c. So c is equal to 1. So f prime of x is equal to negative 1 over x plus my 1. Now, I need to find f of x. What's the antiderivative of this? It's f of x equals negative. That's right, natural log of x. X is positive. I don't need absolute value. Because I'll do it anyway. Because you know why? If I do that anyway, it's right. Plus x plus d. So what's f of x? 0 equals negative natural log of 2 plus 2. I know what it is. Doesn't matter. Plus d. So what's d equal to? Yep, ln of 2 minus 2. So add this to both sides. Minus 2. That's it. That's all there is for day 1. Just finding derivatives. Shouldn't be terribly difficult. Do you want to finish this off and do day 2 or do it tomorrow? Okay. It's fine with my me because my throat really hurts. Yes. Okay, you have the rest of the time to work, and I know this is a tough week for you to try to get work done, but get your work done. We really can't slide. We're about 2 days behind schedule, so we can't slide at all. We got to. Oh, I'll grade them during class, but I have the first part done. But some people might have to leave.